You know that screen on your phone? The one that's perfectly, impossibly smooth? Or how about those smart windows that can tint themselves on a sunny day? Ever wonder how that's even possible? Well, the secret is a process that sounds like science fiction. It's like painting with atoms. Today, we're diving into chemical vapor deposition.
I mean, seriously, just think about that for a second. How would you even begin to create a coating that's only a few atoms thick? It sounds completely impossible, right? But here's the thing. This incredible technology is already all around us, shaping our world in ways you might not even realize.
And this isn't just some experiment locked away in a lab. Nope, this atomic-level artistry is out there in the real world. It's creating these stunning surfaces that you see and that you use every single day, often without a second thought. We're talking about everything from those smart windows that adapt to the weather to glass that literally cleans itself. And you know those vibrant, durable, almost metallic colors you see on modern buildings? That's from materials like titanium nitride. So what's the secret sauce that connects all of these innovations? It's a process that is just unbelievably precise.
It's called chemical vapor deposition, or CVD for short, and it is a truly revolutionary way to build materials from the absolute ground up, literally one atom at a time.
Okay, so let's get just a little bit technical for a moment. In a nutshell, CVD works by taking special gases, we call them precursors, and feeding them into a chamber. These gases then react on a heated surface, the substrate, and they form an incredibly thin and uniform solid film. You're basically growing a new layer right on a surface.
But let's ditch the textbook definition. The absolute best way to understand CVD is to think of it as painting with gas. Seriously. Instead of a brush and paint, you're using vapor and chemical reactions to create a flawless, atomic-scale masterpiece. And that simple idea is the key to all of its power. So how does this incredible painting with gas actually happen? Well, you might be surprised to hear that it all boils down to a pretty simple four-step recipe. First, you transport the precursor gases into a reaction chamber. Simple enough. Then, those gas molecules adsorb, which is just a fancy word for stick, to the hot surface you want to coat. Next, the heat kicks off a chemical reaction, causing the gas molecules to break down and form that new, solid layer. And finally, any leftover byproducts are just swept away. It's this precise, continuous dance of molecules, all happening at a microscopic level.
And this is where the real magic happens. You should think of these parameters like the control dials on a high-tech oven. By precisely adjusting the temperature, the pressure, and the gas flow, scientists can control everything from the thickness of the film to its actual atomic structure. A higher temperature might create a super durable coating, while a lower one might make it more flexible. It's this level of control that makes CVD so incredibly powerful.
Okay, so now we get the process. Let's talk about the incredible things we can actually create with it. Because once you master these atomic-level controls, the possibilities are, well, they're pretty much endless. This isn't just a scientific curiosity. This is technology that's actively shaping the world around us. The applications of CVD are truly mind-boggling. It's the technology that lets us pack billions of transistors onto a single computer chip. It's what makes smart windows and more efficient solar panels possible. It's even used in medicine to create life-saving implants that our bodies won't reject. From the smallest microchip to the largest skyscraper, CVD is driving innovation everywhere. Let's just talk about precision for one more second. We're not just talking about thin layers. We're talking about building materials with a precision measured in nanometers. For perspective, a single sheet of paper is about 100,000 nanometers thick. This is a level of control that lets us engineer materials with properties that were once just thought to be impossible.
Now, as amazing as CVD is, it's not without its challenges. On the one hand, it creates these incredibly durable and uniform coatings that can cover even the most complex shapes. But on the other hand, it can be expensive, it's very energy intensive, and sometimes it involves working with pretty hazardous materials. It's really a classic trade-off, balancing that incredible power with some practical limitations.
So, what does the future hold for this incredible technology? Well, scientists and engineers are already working on ways to get around its limitations and unlock its full potential. The next generation of CVD, it's shaping up to be smarter, safer, and more versatile than ever before. The future of CVD is incredibly bright. We're seeing the development of greener, more environmentally friendly precursor gases. There are new techniques like plasma-enhanced CVD that make it possible to coat flexible materials like plastics. And of course, AI is getting integrated, leading to smarter, more automated systems.
The whole goal is to make this powerful technology even more accessible and sustainable.
So, as this incredible technology of painting with gas keeps evolving, it leaves us with a really fascinating question. What's going to be the next canvas for this atomic-level artistry? Could we see self-repairing clothes, smart food packaging, or something else we can't even imagine yet? The future is a blank canvas, just waiting for the next masterpiece to be painted, one atom at a time.